All right. Let's take a look at this. This is an SAT preps question using our inequality systems. So we're given two inequalities and we're asked to figure out where there's no solutions, which means we need to know where the solutions are. So if you graph both of these inequalities, so we're going to graph this guy, and let's switch this one to red. We need to graph this guy. So graph those two pieces. Nothing else, we should be able to do that. Hopefully. Especially since we have a test coming up later this week. So our blue one, I'm going to graph that one. I'm going to switch my stylus. It's in our slope-intercept form, so I'm going to start at that one. We're going to have a slope of 2. Since it has that equal sign, we should have had a solid line. And then which way do we shade? Do we shade above it or do we shade below it? You can test a, whoa, holy cow, big point. You can test a point. You can use a 0, 0. Are we shading above or below? What'd you get? Because at this point we should at least have that one done. Because we do these during the bell work. Not so you don't wait for me to do them, right? Totally right. That's absolutely what we do. We shade above or below on the blue one? On this first one. Above. Bless you. So this one's going to be up here. And then the second line is very, very similar, except we're starting at r minus 1. We have our slope of 1 over 2. It's going to look like that. This one gets a dotted line because we are greater than, not a greater than, equal to. So I need my line to be dotted. And on this one, do we shade above or below? Above. Because again, I could test 0, 0, and it would show that this one works. So our solutions are going to be every place where we have both red and blue pieces. So it's this purple section over here. So if all we had to do was to graph the system, it would be that. But they asked us a question. They said, which of the quadrants, and they gave you a little picture here to remind you what they're called, which of these has no answers to this system? It's Roman numeral, so it's 1, 2, 3, or 4. So this one is quadrant 1. That's this corner up here. Does this have solutions in it, in this quadrant? Yeah, this little chunky right here. Does quadrant 2 have solutions in it? Yes, almost the entirety of quadrant 2. There's just one little spot that's not. What about quadrant 3? Does it have solutions in it? Yep. What about quadrant 4? Does it have solutions in it? No. So the quadrant that contains no solutions to the system would be quadrant 4. This guy. So this would have an answer of C. So this came from the practice questions for the SAT and the PSAT per the SAT and PSAT websites. So like this is something that they might ask on the PSAT in like 2 weeks. Huh? I just didn't hear what you said. For real. Okay. We have one concept left to do in this chapter. We are going to work on that today and tomorrow. So it's the same thing. So we are going to be in our notes packet. We should only have like 2 pages left. So it is page 18. And it has a whole bunch of steps off to the side. It's got it in a table. I've kind of just taken the table out so that I can have it all on one page. And what we're going to be looking at here is we're going to be looking at systems that have 3 variables. They are creatively enough called 3-variable systems. And that just means it has 3 different letters. So we've done a whole lot of systems that have x's, that have y's. Now we're going to rock some x, y's, and z's. And we can do this. It uses the same tools we did for 2-variable systems. Like we can use our elimination. We can use our substitution. More often than not, these are set up better for elimination, which is part of the reason I wanted us to really think about elimination on Friday again, that we were kind of stuck on. So a lot of times, this is going to be easier to work with elimination. But substitution does work. It's just going to be a little messy. So what we're going to do is we're going to need to use all 3 of these equations. And because we're going to need to use all 3 of them a couple of different times, I'm going to label them. I'm going to call this top one equation A. I'm going to call the middle one equation B, and the bottom one equation C, just so that we can talk about them. It's easier than saying the top equation, and then the middle equation, or then the bottom equation. Equation A, B, and C. You don't have to name them. I just find it easy to talk about stuff that way. And what we're going to do is we're going to look through here, and we need to eliminate out one variable in here. So what I'm going to do is I'm going to break these up into groups of 2 because it's really hard to work with all 3 at the same time. So I'm going to break these up into groups of 2. I want to take 2 equations and eliminate out one variable. And then I need to do a different pair of 2 to eliminate out the same variable. So remember, when we're working on elimination, I need the same number with opposite signs. If I look through here, on the x's, I've got a 1, a 2, and a 4. That's not bad, but I've seen better. I've got a -3, a +3, and a -3. Not too shabby there at all. I've got a +3, a -1, and a -1. So I'm going to work with those 3's first because I already have the same number with the opposite sign with A and B, and I have the same number with the opposite sign with B and C. So I have 2 pairs that can eliminate out the same variable. So I'm going to write these 2 pairs. This would be step 1, just because you guys have boxes, I don't. And we are going to select a pair of equations to eliminate out one variable. I'm going to use equations A and equation B. And I'm just going to copy them down here. If I take my x minus 3y plus 3z equals -4, and that 2x plus 3y minus z equals 15. And we are going to eliminate those out exactly the way we would have last week, adding them together. I already have the same number with the opposite signs on my y's. So when we add these together old school style, I've got my x plus 2x. That's going to give us our 3x. I've got my -3y plus 3y. So that's going to be plus 0y. And I've got 3z plus -z, or -1z. And so that's going to become a plus 2z. And then we have -4 plus 15. That's going to give us 11. So when we add those together, my y's eliminated out. I need one of our letters to cancel out. Since this guy canceled out, we did just fine. And what we get is 3x plus 2z equals 11. That is step 1 right there. Questions on anything that happened in that particular step? Okay.
It's the same thing we did last class.
Very much. It's just like kind of doing that on steroids. Because step 1 is to do that with one pair of equations. Step 2 means I need to pick a different pair and eliminate out the same variable. I need to get out those y's. So we did A and B before, the top 2. Now I'm going to take the bottom 2 because they have that same kind of setup. I can take my 3y and my -3y. I can get that same variable to cancel out. So for my step 2, I'm just going to put that over here. You guys can put it in the box for step 2. I just don't have that much space up here. I'm going to use equation B and equation C. So I'm going to copy those over. My 2x plus 3y minus z equals 15. And my 4x minus 3y minus z equals 19. I always put this little crossbar on my z just because otherwise it starts to look like a 2. That's the only reason for it. If your z's and 2's look different, valid. You don't have to put the little crossbar. It's not a thing. It's just because my handwriting looks weird. So then we're going to do the same thing. I'm going to add them together using our elimination. I want those y's to cancel out. So we're going to add together. We've got our 2x and our 4x. That's going to give us our 6x. 3y plus minus 3y is going to give us a 0y. Minus z is a minus 2z. And that's going to equal 15 plus 19, which is going to be 24. So the whole point of this is that I canceled out that same variable. I have to cancel out the same variable in steps 1 and 2. Has to be, has to be, has to be. So this one, once we get rid of those y's, we get that 6x minus 2z equals 24. Questions on those 2 steps? As it's written. Yes, dear.
Why did you use equation B instead of A when you used the second one?
So the reason I chose B instead of A for this one, because if I used A, I'd have minus 3y and minus 3y. I would need to multiply to get those to have that same number and opposite sign. Those have the exact same sign, and if I was to add them together without multiplying, I'd get negative 6y, and it wouldn't cancel out. So because I need them to cancel out, I want to have the same number, opposite sign. And since the B was already with the opposite sign, I use that one. You can use any pairings that you want. We need to use 2 different pairings. We need to make sure we use all 3 equations. But we can aim for any variable. I can use whichever pairings we want. I might have to multiply. But on this one, A and B were set up really nicely, and B and C were set up really nicely for X. Okay, so that's step 1 and step 2. What we got at the end of step 1 and step 2 is I got a 2-variable equation and a 2-variable equation. That's a system we can solve. My green equation and my purple equation up here, for step 3, we need to solve that system. So I'm going to stack them on top of each other real quick. So I'm going to do this. So this is for step 3. I'm going to take my 3x plus 2z equals 11 and my 6x minus 2z equals 24. And we want to solve this system. Now this is just like the ones we did last week. It has a z in it, but that doesn't change what we're doing. So on this one, we could look and see if we need to multiply by anything. My x's are not that far away from each other, but my z's, I've got a positive 2 and a negative 2. So I am ready right now to eliminate out my z's. If we needed to multiply, we could. We did that last week with our elimination. But this one's actually set up right for it. So we can just come through and add these ones together. Because if I add my 3x plus my 6x, we get a 9x. And then 2z plus negative 2z, we get 0 z's. And 11 plus 24 is 35. Right?
Well,
What's up?
how do you get 24?
Oh, should be 34. There we go. I was going to be like, something's off. Yeah, 15 plus 19. I did 19 plus 5. That should not be 24. That should be 34. Right? Double check me now because clearly my brain's not working right. Ponytail's too tight. Yeah, you see me make a mistake like that. Please, please, please call me out. So I was just going, that's not what we should be because we should be at 45 down here. There we go. That's better. That's significantly going to be way more pleasant. I'm like, that's about to be real fraction. Thank you for that, dear. Because, yeah, that was going to make it a whole lot harder. And honestly, that'll be where I see the most mistakes. So it's a very, very totally intentional example of where we get the most mistakes. We think really, really hard on the setup and on the adding, and it's the constants that we go like, oh, yeah, I can do that. And that's where we make mistakes. Just like that. Oh, my gosh. Examples. Okay, so now that I've fixed all that stuff, now we're here at 9x plus 0z equals 45, which means our z's canceled out, and we're left with just the 9x equals 45. What do I do to figure out what x is? Divide both sides by 9. I'm going to find out that my x is what? What is 45 divided by 9? 5. So now I know my x is 5. I don't know what y is, I don't know what z is, but I know x is 5. I could find out what z is because I have here an equation that has x and z tied together. I have here an equation that has x and z tied together. I can use one of them to figure out what my z is. I'm going to use the green one because it's got smaller numbers. So we're going to do just like we did in our systems before where we're substituting it back in to get our other piece. This time we're just going to have to do it a couple of times. So I'm going to take my 3x, but now I know my x is 5, plus 2z equals 11. So I'm just substituting my x of 5 into this equation so that I can figure out what z is going to be. Well, my 3 times 5 gives me a 15 plus 2z equals 11. How do I solve for z? I'm going to figure out what z is. We don't need to factor it. Good thought, though. I don't have a square, so I don't need to factor. Good idea, though. What should we do? Yep, subtract the 15. Minus 15. That's going to give us 2z. 11 minus 15 is a negative 4. Divide by 2. Exactly right. Divide by 2. Divide by 2. And that would be why I put crossbars on my z's, because those are the z-eest looking 2's ever. So my z equals negative 4 divided by 2, which is negative 2. So now we know what x is, and I know what z is. I just got to figure out y. So that is the end of step 3. Step 3 gets us all the way down to knowing both x and z. We finished solving our 2-variable system. We got our answers for both letters. Our last step, our step 4, is to take our 2 values that we found. I found my x is 5 and I found my z is minus 2. And I need to put it back into one of my OG equations. One of the original guys. I could use A, or I could use B, or I could use C. It genuinely does not matter. It genuinely does not matter. We're going to pick one of them. We're going to substitute in the x that we know and the z that we know, and that'll let us find b. And it genuinely does not matter which one we use. Since we're looking for y, I'm going to use the one that has y with a positive coefficient, so I'm going to use b, just because then we don't have to worry about so many negatives, hopefully. So I'm going to use b, just because that guy is positive. That is genuinely the only reason I'm picking it. You don't have to do that one. You can use any of the three equations. You don't always have to use a positive coefficient. You can do whatever you want. But since negatives tend to throw us off a little bit, I'm going to use the one that's going to give us the least amount of negatives. So our step 4, I'm taking the middle equation. I'm taking equation B. That's our 2x plus 3y minus z equals 15. I'm just copying it down again because it's too far away on my screen. And then I'm going to substitute in my x and my z. So I know we're going to have our 2x, but our x is 5, plus 3y minus our z, and z was negative 2, should equal 15. So I'm substituting in my x, I'm substituting in my y. I'm sorry, I'm substituting in my x, I'm substituting in my z, because those are the ones I know. And then we can simplify. This ponytail's gonna drive me nuts all day long. It's okay, commitment to the bit. So then we have my 2 times 5 is gonna give me a 10, plus my 3y minus negative 2. What's that gonna be when I simplify that? What happens when we have a minus negative? Plus. The 2 negative signs cancel each other out, so we get plus 2 equals 15. So then we could combine some like terms on this left-hand side. So I get my 3y plus 12 equals 15. Does my 10 plus 2 combine together? What do we do next? Subtract the 12. And minus 12, and I minus 12. And we're going to get our 3y equals 15 minus 12 gives us 3. So what does our y equal? 1. Because we would divide both sides by 3. So now I know my x is going to be 5, my y is going to be 1, and my z is going to be negative 2. Our last bit is to write this like we would a point. When we had x's and y's, we did it in our ordered pair, x and then y, alphabetical order. I have 3 now, so it's just going to be 3 of them, still alphabetical order. X, then Y, then Z. It is called an ordered triple. This will be like the only time we see those in this course, because this would be 3-dimensional graphing if we had that. So our answer is going to be our X of 5, and then our Y of 1, and then our Z of negative 2. This is how we should write it. It's always in alphabetical order when it comes to ordered pairs. X then Y then Z. If we ever gave you A's and B's and C's, it would be A then B then C. It's alphabetical order. Okay. So these are awkward and long and unpleasant. And they have lots and lots and lots and lots of steps. We have to do 3 sets of elimination in them. Questions on this first one? Because we're going to do one more today, and then we'll do a third one tomorrow. And that'll be it. These are the last part of this chapter. Okay. So on the next page, you've got 2 more examples. We'll do 1. Yes, that's one. This one's number 1 on page 19. The last one, page 19? Because we double page? No, okay. And then we'll do 2 tomorrow, just because I don't want us to be trying to speed through it. So again, I like to label my equations just because it's easier to look at and easier to kind of describe. So I call this one A, I call this one B, and I call this one C. I don't use numbers because I don't want to wind up being confused with what numbers they are, so I just use A, B, and C. And on this one, Our numbers are not icky. I've got minus 1x, minus 6y, and minus 2z, minus 1x, 5y, and 3z, 3x, minus 2y, and 4z. But I don't really have anything that's set up super duper perfect for everything. I could get my x's to eliminate out pretty quick. A and B would cancel out right there. But C isn't partnered up with anything perfectly. My y's are not far off, but they're not particularly pleasant with the 6, the 5, and the 2. And the same thing with my z's. I've got a 2, a 3, and a 4. They're not perfect. It's workable, but they're not super pleasant. So when I don't have something set up perfectly, I'm going to work with something that has a 1 or a minus 1. So I'm going to aim for my x's first. My first set of elimination is I'm going to take out the x's. Because I have an x that has a 1, that's going to be our easiest to multiply when we need to do our second round. Our first round, easy peasy. We can do this with equations A and B. So our step 1, where we're going to take two equations and eliminate out one variable, I'm going to use equation A and equation B. Those first two. Because I have my x that has the same number, opposite sign. So I'm going to rewrite those over here just so I can have them. My x minus 6y minus 2z equals negative 8. And my minus x plus 5y plus 3z equals 2. Oh, my handwriting is beauteous. It's so pretty. I don't judge your handwriting, John. Like, as long as I can understand what it says, we're fine. So then we're going to add these two together. Especially when I have to have it zoomed out for a little bit. My handwriting gets real bad. So we're adding these guys together, ignoring everything else right now. So my x plus my minus x, that's 1x minus 1x, we get 0 x's. That's the point we were aiming for our x's. I got my minus 6y plus 5y. That's going to give me a minus 1y. And my minus 2z plus 3z. That's going to give us 1z. And then we have our minus 8 plus 2. That's going to give us a minus 6. So the whole point is that these x's canceled out and we got rid of one of our variables. So we're left with minus 1y, or just minus y, depending on how you like to put it. And our plus 1z, or just plus z, equals negative 6. If it helps you to have the ones, have them. If it does not help you to have the ones, don't have them. It genuinely makes no difference. That gives us our first equation where we eliminated out our x's. Now we need to look at our original equations again. To get to our step 2, I need to eliminate out the same variable but with a different pair of equations. Which means I can't use A and B directly anymore. I need to have something that uses C. So we need to mix C with one of these guys. Well, I could use equation 1 or equation A, because I have that 1 there, I can multiply anything. Since I want to wind up with the same number, opposite sign, I'm actually going to use B, because it already has that opposite sign and I don't want to have to multiply by a negative for all the things, ew. But I can take equation B, and if I want it to have the same number, what do I need to multiply B by for my x's? I want the x's to have the same number, so the 3, and the opposite sign. Yeah, I'm going to multiply B by 3. So I'm going to have equation C, and I'm going to take B times 3. And so I will usually write that down. I'm going to take equation C, and I'm going to take B times 3. That's how I'll write that, B dot 3. So my equation C, when I write that, is going to have our 3x minus 2y minus 4z equals 18. And b times 3, we're going to take our minus x times 3. That's going to give us a minus 3x. Our 5y times 3 is going to give us plus 15y. Our 3z times 3 is going to give us a plus 9z. And it's going to equal 2 times 3, which is 6. So we're multiplying absolutely everything in here by that 3. Everybody. And then we can add them together. Because now I have the same numbers with the opposite sign on my x's here. So my x's should eliminate out. So my 3x plus minus 3x is going to give us a 0x. My minus 2y plus 15y is going to give us a 13y. Minus 4z plus 9z is going to give us a 5z. And that's going to give us an 18 plus 6, which is 24. So again, the whole point is that my x is canceled out. And we're left with just our 13y plus 5z equals 24. Questions on those two rounds? With round 1 of elimination and round 2 of elimination. Once we get here, we're trying to solve this system. I'm going to look at this guy and this guy, my red one and my green one here. You could do this with our substitution if you want to make one of these be a z equals or a y equals. Absolutely valid. We can also do this with our elimination. Since we've been kind of in the elimination zone, I usually just kind of stick with it. But if you want to switch and do substitution here, it's totally valid. On this one, you could just add y to both sides and get a z equals. Totally valid, and then you could substitute. Absolutely works. I just tend to be like, I'm already in the zone on elimination, so I'm just going to keep going with it. If we think about our minus y plus z equals minus 6, and our 13y plus 5z equals 24. Again, I could solve this using substitution, but I'm going to go ahead and do elimination. We could go for our y's, multiply both of these by 13. I could go with my z's, multiply everything by -5. Genuinely, it does not matter. Genuinely, it doesn't. I'm going to go with the z's because we tend to feel better multiplying by 5s than we do multiplying by 13s. So to get my z's to cancel out, I need to multiply this whole equation by -5. That would give me the exact same number with the opposite sign here. So when I write my green equation again, which I'll just put that as a darker green, we're going to have minus y times minus 5. We get 5y minus 5z equals a positive 30. And then our red equation is staying exactly the same. 13y plus 5z equals 24. And we're going to add those together. And we're almost there. 5y plus 13y is going to give us an 18y. Then we're going to have our minus 5z plus 5z. That's going to cancel out. We're going to wind up with 0 z's. And our 30 plus 24 gives us a 54. So this guy canceled out. So we're left with just our 18y equals 54. So what does our y equal? y equal? 3. 54 divided by 18 gives us 3. So now I know one of my letters. I know that my y is 3. Now we got to go back and figure out what x is, figure out what z is. I could use this equation. I could use this equation. I could use this equation. I could use that equation. Genuinely does not matter. I'm going to go ahead and use my first green one because I like the fact that it does not have gabillions of coefficients. So I'm going to use this one, which is the same as this guy right here, where we're going to substitute in my, minus y, but now I know my y is 3, plus z equals negative 6. Just putting a barrier right there. So that's going to give us that negative 3 plus z equals negative 6. So if we add 3 to both sides, we get z equals negative 3. So now I know my y. Whoa, that was not that laser pointer. There we go. Now I know my y and I know my z. We got to figure out x. I'm going to use a because it has x with no coefficient. You can genuinely use any of them. It does not matter. I'm just going to use this one because it's got the simplest x. So I'm going to take that first equation. My equation A is what I'm using. Where I'm going to have my x minus 6y minus 2z equals negative 8. And I'm going to substitute in that y and z that we know. My x minus 6 times 3 minus 2 times our negative 3 equals negative 8. And yeah, this one has a lot of minus signs, but we can do this. So we just need to be careful. Because when we simplify this, we get our x minus 6 times 3 is 18. Minus 2 times minus 3 gives us a plus 6 equals negative 8. I can combine those like terms together, my minus 18 and my plus 6, to get x minus 12 equals negative 8. And then when we add 12 to both sides, what do we get? What does x equal? Negative 8 plus 12. Positive 4. So my x is 4, my y is 3, my z is negative 3. Our very last step is to write this as our ordered 3 pieces, or our ordered triple, or ordered pair with an extra bit. Where I put my x, and then my y, and then my z. Alphabetical order every single time. Minus 3. So this guy is our answer. Tomorrow we will do one more. We'll do that last one on page 19. And then after that, it's going to be reviewing for the test. So tomorrow we'll have time to work on stuff. We should have time to finish up that homework that is technically due Wednesday, but we should be able to have it turned in tomorrow. Hopefully the date on this might be off. We actually, because it's homecoming week, are not going to have a Canvas activity this week. Oh my gosh, presents, yay, huzzah. So our chapter test is actually scheduled for Thursday. I did not update that date either. So we're having our test on Thursday. Homework 6 is due Wednesday, but you can probably get it in tomorrow because we will have time when we're done, because we're only going to do one of these. Homecoming is this week. Thus this. I am extra, but I'm not usually this on a random Monday extra. Usually. I'm not going to say never, but